Hey there, and welcome back to Software Explained Simply. This is episode 4, and we're talking about loops. This is still kind of in our programming fundamentals theme. Loops are a critical part of any programming language, and they're very useful. So, loops are what we're talking about today, and that's it. They're kind of a big topic, and they're very important to understand, so we'll take an entire episode dedicated to them. So loops really just do one thing, and that's they allow you to do repetitive tasks. Computers are great at doing repetitive things very quickly, and people are not. So a loop will allow us to get a lot done for very little effort on our part. Now, if we go back to our arrays that we've been dealing with, if we wanted to print every value in this array, if it's got 4 elements, then we would just print it out 4 times. So here again, I'm using Ruby. And the put statement in Ruby kind of stands for put string, so it prints the text basically. So we can print out each of our elements, starting with element 0, because arrays are 0 indexed, if you remember that from a previous episode, up through index 3, which is the last item in our 4-element array we have here. And that's not too bad, that works. But what if our array has more than 4 things in it? So like, what if it had 100 things? Now we're writing 100 put statements, and that's not very fun or practical. But I mean, arrays could have millions of things or more. And so at this point, it becomes impractical or impossible to use in this fashion. So we need a better approach when we're dealing with a lot of things. And we also need a better approach when we're dealing with an unknown number of things or a number of things that change. So for example, if your app displayed a list of all the users maybe in an admin section, on day 1, you may have 1. A week later, you may have 10. You may have 100. You may have 6,000. And you can't just hard code those numbers. You need to be able to do the problem generically, no matter how many you have. And that's something you'll find across programming a lot in general is you're trying to use software to develop a generic solution to a problem that handles all the edge cases. So loops are going to help us with this unknown number of things problem specifically. So a loop basically, for every item in a collection, it lets you do something with it. So if I've got 5 things or 10 things or 0 things, and I want to do something for each of those things, a loop will let me do that. Before we talk about loops, I want to mention this one quick thing because you'll see it in a second, and that is the post increment operator. So if you had a variable called I and you did I++, in most languages, that's pretty equivalent to I plus equal 1, which is shorthand for I equals I plus 1. So basically, it's taking your variable, it's adding 1 to it, and then it's storing it back in the variable. And we'll see that here in a second. Okay, so here's our first loop, and this is a for loop. And here's the basic structure of a for loop. We have the keyword for, and then inside of the parentheses we have 3 things. We have the initial value, we have the while condition, so how long do we want to keep doing this loop, and then the third thing is how we're going to change our initial value as we progress through the loop. And then similar to an if statement, we have a block or a section of code inside of the curly braces that is what we're going to do on each iteration of the loop. So to kind of give some practicalness to that, because that probably doesn't make sense just from that generic slide, but so here's a for loop where we're starting at the number 1, we're continuing while 1 is less than 4, and we're just going to print out the value of I. And we're going to do that, and after every time we're going to increment I by 1 using our post increment operator. So we're going to start at 1, we're going to go 1, 2, 3, and we're going to print out that value of I, and we're going to stop after 3. So if we look at this in action, just to kind of illustrate how this works, because I know that probably looks a little jarring if it's the first time you've seen this. So when we start with I equal to 1. And this is represented by our first value there, the for I. So that's what we're starting at. The next thing that happens in the execution is we check our condition. So if I is less than 4, which it is because I is 1. Then we run the code in the loop. So here we're going to print out 1 because I is 1. Now after that, we've executed the loop code. We're going to increment our value. So we're going to do I++, and so I becomes 2. And then now we're going to loop again. So here's where the loop happens. So we start again, I is equal to 2. We run our condition again. 2 is less than 4, which is true. So we're going to run our loop code. It'll print out 2. We're going to increment 2 again, so I++, so I becomes 3. And then we loop again. And so for our third value, I equals 3, we do the exact same thing. We have 3 is less than 4, which is true. We print out 3. We increment 3 up to 4. And then we loop. And so here on this next iteration is where something changes. So we have I equal to 4. And we do our check. Is I less than 4? Is 4 less than 4? And we know that's not true from our previous episode. And so we get false. And so at this point, we leave the loop. And so the results of that is that we print out these 3 numbers, 1, 2, 3. Now, if that doesn't make total sense right now, maybe rewatch that section and check it out. But the good news is that there's a much easier way to do this. And so you really don't ever have to deal with this traditional loop structure, but understanding what's happening here will help you understand what is happening when we go to the newer way. And so it'll give you the context of what happens or why that works. Okay, so let's go back to our array example. So we know that in this array, here I'm switching, I've been using JavaScript, but still in JavaScript here. Here, the first element we know is at index 0 because arrays are 0 indexed. And the last element is at 3. So if we wanted to loop over this array, we could say for I equal to 0, while I is less than 4, increment I, and print out console log x of I. So print out the element in the array x with the value of I. And what we would see is that we'd print out each of those values. So we're going to start at 0. We're going to print it. We're going to increment. So we'll go to 1, print it again, 2, 3. When we get to 4, again, 4 is not less than 4, and we'll stop. Now, another way you can write this while condition is using less than or equal. So if that makes more sense to you, you can say, well, I is less than or equal to 3. So I is less than 4. Or I is less than or equal to 3. And they both work the same way. You get the same result. Okay, now what do we do if we don't know how many things are in our array or our container that we're iterating over? If we remember back to when we dealt with arrays, we showed that we can check the length of the array by using .length. And so the length of this array is 4. And we'll talk more about what that .length is in a future episode because it's important, but we're not quite there yet. And so if we take our loop that we know worked, so we're iterating from I to 4, here I was 0. Instead of this 4, we can use x.length. And so what we've come up with here is actually a generic solution to our problem of knowing how many things are in the array. Because we're going to start at 0, and we're just going to go up to the length. Not equal to the length, because we know that the length is 1 more than the last index. So if there's a 4-element array, the last index is 3. Using this off by 1 thing, which is very easy to mess up with arrays in general and traditional loops, which is why there's a better way to do this. So this would work for any element size array. It'll work for 0, because the while condition will fail. It'd say was 0 less than 0, and it would just skip the loop entirely. It'll work for 100 things, 1,000,000 things, doesn't matter. And then again, just for completeness, if it makes more sense mentally for you, instead of saying I is less than x.length, you can say I is less than or equal to x.length minus 1. Those are both the same. Okay. just to kind of combine some stuff we learned last time, you can do whatever you want inside of a loop. So here we have our same loop, I is equal to 0. We're going up to x.length. And inside, we're going to have our if statement. So this if statement says, if the element of x at the index I, modulo 2, so if you divide it by 2 and take the remainder is equal to 0, then print it out. And so what we've really come up with here is we are printing out all of the even numbers in an array, because anything divided by 2 that's even should have a remainder of 0 because it goes in exactly. And so this prints out all of our even numbers. So you can combine all these things we've been talking about and use them within loops as well. One other kind of side point, you'll traditionally see the initial variable put inside of the loop construct itself. So instead of declaring it outside of the loop, you'll just say for using JavaScript, for var I equals 0. So since you don't really care about that value outside of the loop, you're only using it to keep track of the increment, you can remove an extra line and just put it inside the loop. Okay, so one final example before I show you the good way. And this one is a little hairy. Here we have 2 arrays, and we're going to iterate through x again. X didn't change. But for every iteration of x, or every value of x, we're going to iterate completely over another array called y. And so I've printed out the value of I and j here, which are incrementing variables. And so you can look at those and see that we start with I and j equal to 0, and then j is incremented completely until the j loop is met, and then we increment I. So for every value of x, we're going to iterate completely through y before we increment x again. And so I is equal to 0, we go j 0, 1, 2, 3, then we bump up I, j 0, 1, 2, 3 again, and we proceed like that. Now, if we look at the values of x and y that we're dealing with, by changing it just a little bit, we'll see that similar concept. We pick in the first value of x, which is 1, and then iterate through y completely. So 5, 6, 7, 8. Then x is equal to 2, y is 5, 6, 7, 8 again, x is equal to 3, 5, 6, 7, 8. Finally, until we get x equal to 4, which is the last value, y equals 8, which is the last value. Now, that if the regular loop seemed hairy, that probably seems crazy, and it is, and it's very easy to mess up, even for seasoned programmers. There's a reason that off by 1 errors is a phrase, and it's because it's very easy to do. With arrays and with loops, especially with zero-based indexing, like that's just not your natural mental way to think about stuff. So there's a better way to do this, and this is the part where, kind of like where you learn long division and then your teacher said, okay, take out your calculator and forget everything you just learned. This is the take out your calculator part. Okay, so if we switch back to Ruby for a second, if we have our basic array, Ruby has, and many other languages have, a concept of iterators. And like the name suggests, an iterator helps you iterate over something. And so in Ruby, if I wanted to iterate over this array, I don't have to think about the index. I don't have to think about it being zero-based index. I don't have to think about the length. They give us this nice each method, which we'll talk about next episode. But each allows us to just get each element and do something with it. So very simply, x.each, and then we pass a block. We're going to call each item as we go through it in. So it's going to give us every item. It's going to call it in for that iteration of the loop. And then we can print it out. So we can use puts, the Ruby print method. And so, just like the other examples, that prints out 1, 2, 3, 4. And here we're not dealing with indexes. We're not dealing with length. We know we have a list of things, and we just want to receive each one of those things one by one until we're done with them. And this is not only much easier to deal with and nicer to deal with, but it's also less error prone because we're not dealing with indexes, we're not dealing with links, which can get tricky. Now to show a JavaScript example, it has a very similar construct. There's the for each method or function. And we'll talk more about functions in the next episode, so hold tight, we're almost there. But similar concept, we're going to take each one of these things one at a time and do something with it. So I can't remember the last time I wrote a traditional for loop because iterators are just so nice and there's no reason to use one. It's more just a mental exercise or really to understand what these iterators are doing in the background for you. Now, just for completeness, because I can't remember the last time I used a for loop, and I definitely can't remember ever using a while loop in my nearly 8 years of professional software development. But just for conceptual completeness, there's a thing called a while loop, which does the same thing, and if you compare it to a for loop, it has pretty much the exact same parts. So we have an initial state, we have a condition that we run the loop while it is true, and then we have an incrementer. And don't really have to worry about this. It's more just for, mental completeness. But even when people use traditional for loops, they try to not use while because they're also easy to mess up. It's easy to have them loop infinitely if you don't set your condition or your increment quite right. So just kind of fun knowledge, the more you know. Okay, so let's do a quick recap. So loops allow us to do repetitive tasks easily. They allow us to do repetitive tasks on an unknown number of things, which is incredibly useful. There are traditional loops, so using for or while. There's also a do while loop, but again, not even worth learning about. And modern languages and frameworks have built iterators on top of that because they're kind of a pain to use and they're error prone. So we have things like each and for each, and I'm sure whatever modern language you use has an equivalent. Okay, so some stuff to practice from this episode. You can practice iterating over arrays and printing their values. You can iterate over an array of numbers and print out all the odd ones. I showed an example for even previously, so odd should be pretty easy to get from that. You could also sum all the values. So take an array of numbers and sum them up and then print that out. And as a hint, you might use another variable in that process. If you're looking for a challenge, you could iterate over a nested array. So my example there is I have an array that has 2 elements, and the first element is also an array that contains the values 1, 2, 3. The second element is an array containing the values 4, 5, 6. So if you aren't scared off by the nested array example, you could take a crack at that. And then if you want extra hard mode, then you can do all that with traditional loops and then do it with modern iterators, which the modern ones are obviously more easy. But that's it for this episode. Hope you enjoyed it. We're going to talk about functions or methods next. And those are fun and starting to get into the good stuff. So hope you enjoyed. Let me know if you have any questions or comments below, or reach out to me on Twitter. I'm at John Mosesman pretty much everywhere online. So see you next time. Thanks.